Again, pretty much along the same lines as we did before, and we can show that if G is a secure PRG, then in fact we get a secure PRF on 0, 1 to the n, on a very large domain. So that's fantastic. So now we have, essentially we have a PRF that's provably secure, assuming the underlying generator is secure, and a generator is supposedly much easier to build than an actual PRF. And in fact, it works on blocks that could be very large, in particular 0, 1 to the 128, which is what we needed. So you might ask, well, why is this thing not being used in practice? And the reason is that it's actually fairly slow. So imagine we plug in as a generator, imagine we plug in the salsa generator. So now to evaluate this PRF at 128-bit inputs, we would basically have to run the salsa generator 128 times, 1 time per bit of the input. But then we would get a PRF that's 128 times slower than the original salsa, and that's much, much, much slower than AES. AES is a heuristic PRF, but nevertheless, it's much faster than what we just got here. And so even though this is a very elegant construction, it's not used in practice to build pseudo-random functions, although in a week we will be using this type of construction to build a message integrity mechanism. So the last step is basically, now that we have built a PRF, the question is whether we can actually build a block cipher. In other words, can we actually build a secure PRP from a secure PRG? Everything we've done so far is not reversible. Again, if you look at this construction here, we can't decrypt. Basically, given the final output, it's not possible to go back, or at least we don't know how to go back to the original input. So now the question of interest is, can we actually solve the problem we wanted to solve initially? Namely, can we actually build a block cipher from a secure PRG? So I'll let you think about this for a second and mark the answer. So of course, I hope everybody said the answer is yes, and you already have all the ingredients to do it. In particular, you already know how to build a PRF from a pseudo-random generator. And we said that once we have a PRF, we can plug it into the Luby-Rokov construction, which, if you remember, was just a 3-round Feistel. So we said that if you plug a secure PRF into a 3-round Feistel, you get a secure PRP. So combining these two together basically gives us a secure PRP from pseudo-random generator. And this is provably secure as long as the underlying generator is secure. So it's a beautiful result, but unfortunately, again, it's not used in practice because it's considerably slower than heuristic constructions like AES. Okay, so this completes our module on constructing pseudo-random permutations and pseudo-random functions. And then in the next module, we're going to talk about how to use these things to do proper encryption.